Thank you very much for having me here as a guest. There's friends in the audience and great colleagues, and there's people who live with a disability and parents of children with disabilities here, so welcome to all of you. This is a great topic and it's dear to my heart, and it became dear to my heart when I had the chance to meet Christopher Reeves some years ago, and he talked about his great hope from what stem cells might offer him. And at the time the field was pretty new, and I went and asked his neuroscientist, well, what about cerebral palsy? And he paused for a moment and scratched his head and said, I don't see why not. And I have been chasing this topic and good science ever since. So today we'll have a look at what are the options for people, what's the research up to, and a little bit of an introduction to stem cells. So if you're starting to think about it, what are the different kinds of cells that might be of interest? Okay, so it's estimated that perhaps as many as 1 in 3 people in the future might benefit from regenerative medicine. And so that's meant that stem cells has become the new medical frontier. And it means that we have this great interest in what they might offer us both for now and in possibility, people thinking about ageing as well. And for patients though, it can be very difficult to sort out what is the fiction from the facts and what's the hype from the hope. And we're going to talk about that today. Children, when we think about research, have the most to gain from regenerative medicine, but maybe the most to lose as well if they try something that's not safe. And we must always keep in mind, and Australia has a long history of doing very good clinical research, keeping the balance between benefits and safety in check. The media, of course, loves stories about stem cell, and they impart sort of great possibilities to journalists. On the one hand, there's this human hope, and the other hand, there's these sort of stories of inexcusable scandal, that people's lives are devastated by interventions that don't work. And here are 2 examples. So on one side, a boy who's 2 is the first person with cerebral palsy to be successfully treated with stem cells and taking him from a vegetative state to talking and walking. Now, clearly, this story in 2013 has not fully eventuated, or I could guarantee you, hand on heart, our Prime Minister would give you this treatment for free. So we need to keep working at this science. On the other side, and I put it in black, is a story that was very well known in the media about a baby that died in a stem cell clinic in Germany. And in this case, they said hundreds of British patients, but I know of Australian patients that went there too. And they were selling stem cell treatments, and Germany took a very progressive approach and shut this clinic down. But this clinic was very entrepreneurial, and they just moved to another country with another regulatory environment. So they're still selling these cells. So what we're going to look at today is, just as a starting point, is what are stem cells, so we're on the same page. There are lots of different kinds. What is stem cell tourism and the hype of it? And what is the hope we have from current good clinical research about what possibilities might exist? So there are many, many different words associated with stem cells. And of course we're thinking about human stem cells in this situation. And this is a word cloud of kind of the most common ones used. So which ones are we going to talk about? Here's a little video that explains stem cells.
Bone marrow contains many different types of cells, several of which have specialized roles in the blood. In the early 1960s, it was shown that if bone marrow was taken from one mouse and transplanted into another, rare and specialized cells could travel to the spleen, where they would divide and form small colonies. These colonies contained a mixture of different blood cell types. Incredibly, when these colonies were removed and retransplanted, these rare cells formed new colonies in the spleen of a second mouse. These experiments revealed 2 defining properties of a stem cell. First, a stem cell must be able to self-renew. That is, it must be able to divide and give rise to more cells like itself. Second, it must be able to differentiate. In other words, it must be able to divide and give rise to specialized cells. Since these early experiments, many different types of stem cells have been discovered, and this general definition applies to all of them.